All right, Math 10s, this is video number 3 coming out of lesson 2.4 about the sine and the cosine ratios. So this is our word problem here. A weather balloon is flying at an altitude of 7,000 feet. Instruments show that it's exactly 10,000 feet from the point on the ground where it was released. And so the question is, what's the angle of elevation from the release point to the nearest degree? Often the biggest trouble students have here is just drawing a picture. Once the picture is drawn, the solution of the triangle is actually not that bad. So you don't need to be able to draw a weather balloon or anything, but basically you have your release point on the ground. The balloon has gone up 7,000 feet, but it's also away from the release point, and it's 10,000 feet directly from there to there, which ends up being the hypotenuse of a little right triangle. So we can assume flat ground here, so we have a nice 90-degree angle between the straight up altitude up to the balloon and the ground. And so looking at this triangle, I see that I have, if theta is my angle of elevation, I see that I have opposite and hypotenuse, and so I'm going to use the sine ratio. Sine is equal to opposite over hypotenuse. So sine of theta should be 7,000 divided by 10,000, and which means that inverse sine of that number should give me the angle, and that rounds to about 44 degrees. So the angle of elevation from the ground to the angle where you're looking up at that balloon is 44 degrees. I want to show you just a little brief intro to what comes next. So far today we've been finding angles in every question, because that's what 2.4 is about. But as you can see here, some questions are going to ask you for a side instead. And it still makes sense that we don't have to use tan all the time to find missing sides. In fact, in this question, using tan would be very inefficient, because if I use tan, I'd be able to find the bottom side, the adjacent side of that triangle, which is not what anybody's asking me for. Nobody cares about that side. We care about x, which is the hypotenuse. So given 25 degrees, the 13 is now opposite. So this is another case of opposite and hypotenuse. So sine. Sine of 25 degrees should be 13 divided by x. And if that's true, let's multiply both sides by x and divide both sides by sine of 25. And it gives me that x should equal 13 divided by sine of 25, which is about 30.8 meters for this question. So the next lesson is all about doing that, about finding missing sides. But again, by deciding what sides am I talking about in this question. In this case, it was opposite and hypotenuse. In some of our earlier examples, it was adjacent and hypotenuse. And so using sine, cos, and tan as your trig arsenal is going to allow you to solve a lot of questions a lot more efficiently.